Hello. So in this video we'll study about clippers, that what are clippers, and then we'll design a clipper circuit. We learn to design a clipper circuit on a breadboard. So basically, by definition, clipper is a circuit which clips out some part of a wave. Suppose we take a sinusoidal wave. This is our input sinusoidal wave. X scale is time scale, and y scale is amplitude, say A. So the output of a clipper could be like this. If this is the input, then output could be like this. Okay, like this. So the time period of this waveform is, say, T, capital T. Okay, so half of the time period, T by 2, it is clipped out. Okay, so how we design a clipper circuit? We use diode circuit to design clipper. Okay, so we'll start with a very basic clipper circuit. Okay, in this circuit we'll give a input here, and we'll take output across the diode. So the resistor is R and diode D we are using. So what will happen if the input is sinusoidal wave? This is the V input, is the sinusoidal wave. In the positive half cycle, means this, the positive half cycle, and this is negative half cycle. So in the positive half cycle, this terminal is positive and this terminal is negative. So we know that when in any diode P junction is connected with positive potential and N to negative, then diode will be in forward bias, and a forward bias diode is short circuited. So in positive half cycle, what will happen? The equivalent circuit will look like this in positive half cycle. So what will be the V naught? Because these 2 points, so these points are A and B, these 2 points are shorted, so the output, the potential difference between these 2 points is 0. Okay, so we can say that this is our sinusoidal input, say with amplitude A. So then positive half cycle, in positive half cycle, the output, if we project this here, is 0. We can use a different type of color to indicate this. Okay, then in negative half cycle, what will happen in negative half cycle? Diode P terminal is connected with negative and N terminal is connected with positive. So diode will be in reverse bias, or you can say open circuited. Okay, so in negative half cycle, the diode will act like open circuit, and we are considering ideal diode. Okay, this diode D is ideal diode and not practical diode. Okay, ideal diode means there is no cutoff voltage. Okay, so in silicon diode, in practical silicon diode, the cutoff voltage is 0.7 volt. So the potential across 0 V naught is now what? The input which we are providing here. So the output will replicate the input like this, and in positive half cycle again the output is 0. So you can see that for this input we are getting this type of output, this type of output waveform. Okay, so on CRO, how can we design this? This is breadboard. We know that on breadboard. Okay, so we'll discuss this in next video.